Hi everyone, I would like us to look at pressure. So I have some two real world picture in front of you for a pressure cooker and for a break in water. So what is pressure? What is pressure? What is pressure? Pressure is equals to what? Force over area. The force is measured in Newton, area is measured in meter square. And we have a unit of what? Newton per meter square. So these are two real world examples on where you can really see a real life aspect of pressure. For a pressure cooker, we see that there is an increase in temperature and it causes a rise in pressure inside the pot. And when you drop a piece of wood in water, it could be a brick, there is a pressure on that system which we could determine by knowing the force of the brick and the area of the brick. So let us look at some real world example on pressure. So look at a man having 150 pounds and the area of his feet is 50 inch square. So we can talk about pressure is equals to what? Force per unit area. So we have a force of what? 150. We have pounds force over 50 inch square. So the answer here will be 3 psi. So that is the pressure. And because units are very important, because we need to use the right unit, we could talk about unit as such. 1 Pascal is equal to 1 Newton per meter square. 1 bar is equal to 10 to the power 5 Pascal and is equal to 0.1 megapascal and is equal to 100 kilopascal. While 1 atmospheric pressure is equal to 101.325 Pascal, and we could convert that to kilopascal and we could convert that to bar. While 1 kilogram F over centimeter square is equals to 9.807 Newton per centimeter square. And in Newton meter square, that is the value, and in Pascal, that is the value. And in bar, that is the value. So those are the units you have to pay attention to if you are looking at calculation. Now let us look at pressure with respect to gauge pressure, with respect to vacuum pressure. So for gauge pressure, we know that when we need to talk about the gauge pressure, it's actually a pressure in a gauge, which you see. This is an example of a gauge. So we could talk about the gauge pressure. So the pressure for the gauge is equal to what? Is equal to absolute pressure minus atmospheric pressure. This gives us the gauge pressure. Because we know that the absolute pressure is bigger than the atmospheric pressure. So effectively, this is the absolute pressure. And effectively, this is just the gauge pressure. And effectively, this is atmospheric pressure. So that is the formula for gauge pressure. So whenever you're asked to calculate the gauge pressure, that is the formula you're going to use. Now to calculate the vacuum pressure. So this is the vacuum pressure. In this case, atmospheric pressure is from this reference line, and that is absolute pressure. So the pressure for a vacuum system is equal to what? Is equal to atmospheric pressure minus absolute pressure. That is the vacuum pressure. So whenever you see people asking you to calculate the vacuum pressure, you must always know that it is atmospheric pressure minus absolute pressure. And now let us look at pressure variation. So pressure variation can happen in a case whereby there is a change of pressure. We can see that in a manometer. We can see that if you drop an object in water and it has 2 positions Z1 and Z2, and so on and so forth. So pressure variation, the symbol is delta P, or your height change of P. That is, this stands for difference of, then this is pressure. Or you may say pressure variation. Pressure variation. Some textbook will give you different way to write it, but it is just talking about the pressure difference. So it is the pressure difference. It is always P2 minus P1. So P2 is the pressure at point. So this will correspond to the pressure at point 2. This will correspond to the pressure at point 1. So that is what we call the pressure difference. And it could still be used by, could still be calculated by using the formula density G times change of Z, whereby we have both H2 minus H1. So in a case whereby we are not given pressure, we are given both height 1, height 2, and height 1, or Z2 or Z1. That will still be, this formula will still go. So this is the density of fluid, and this is the acceleration due to gravity, and this is the change in height. That is still used for pressure difference. In fact, it could still be calculated by using this formula. So pressure difference can still be calculated by using which formula? Atmospheric pressure plus rho GH. And that can still be the gauge pressure. So that can still be the gauge pressure. That can still be the gauge pressure equal to rho GH. So there are many formulas that could be used to calculate the pressure difference. So gauge pressure is still a pressure difference. Atmospheric pressure plus density of water times gravitational acceleration, because the water is falling under gravity. In that case, if it is falling at the surface of the earth, we consider but G. So G is also going to be changing, and H is the height. So each of these formula can be used for pressure difference. This can be used, or this can be used. But the take-home message for you, you should know that gauge pressure is still pressure difference, and atmospheric pressure plus density of water times G times H is still going to give you gauge pressure, and pressure at point 2 minus pressure at point 2 is still going to give you the pressure variation. So I'm talking about pressure variation. So this formula can be used for pressure variation. This can be used for pressure variation, and this can be used for pressure variation. So effectively, those are the different formulas that you must keep in mind for pressure variation. Now let us look at pressure variation in a system whereby we have a container having water, and we have is open to atmosphere. So the pressure above water is still the pressure variation, and is equal to atmospheric pressure. So at the top of water, we will call it the atmospheric pressure. At the bottom of water, the pressure variation will become what? Atmospheric pressure plus density of water times G times H. So you can see that pressure variation above water and below water is different. That's what you have to pay attention to. And now, the last two sections. If I have the same water in a cylinder or in a section whereby they have different angle, different shape. As long as the water are all the same, from point E, point G, point F, point E, point D, point C, point B, point A, at a given point that is uniform, the pressure difference will be the same if the fluid are all the same. So look at the reference height is the same. So therefore, the pressure at point A equals to pressure at point B equals to pressure at point C equals to pressure at point D, as long as the fluid we have the same fluid. If we have a different fluid like mercury here, the pressure difference is going to be different for this point and this point. So pH is not equal to PI because the fluid here is different, because we have different fluid. So that is the logic. We have different fluid, so the pressure at the same point for different fluid will never be the same. It will only be the same when we have the same fluid. The pressure will be the same no matter the angle or the shape of the design. The pressure will always be the same. Now lastly, let us look at Pascal law. Pascal law says if we have 2 points, point 1 and point 2, and Pascal law is mostly used when we have the same fluid in a cylinder and we have two different points, we can always say that P1 equal to what? P2. And P1 is what? A1 over we can say F1 over A1 equal to what? F2 over A2. This is the Pascal law. We can determine F1, we can determine F2, we can determine A1, we can determine A2. Remember, F1 is the force at point 1 and F2. So F1 equal to force at point 1 and F2 equals to what? Force at point 2. And A1 area at point 1, and therefore A2 will be area at point 2. So that is the Pascal law. For manometer and barometer, we can talk about the atmospheric pressure, which is going to be what? Density of fluid times gravitational acceleration times the height. So that is the atmospheric pressure. And this section we can talk about the weight of fluid. The weight of fluid is equal to what? Density of fluid times G times H times A. Remember, this is density, this is gravitational, acceleration, gravitational, this is height, and this is the area. So that is the atmospheric pressure for a barometer. So these are the formulas we're going to use, and take note of the density of fluid, and take note of the height, and take note of acceleration due to gravity in your calculation. So in the next slide, we're going to look at some examples.